posted by tomorrow. Also today I'll make another video. I'll solve all the problems of a study guide on the whiteboard. I'll record that one and I'll send it out by evening to you. Okay, if there is no question, let's start with 3.1, which is differentiation rules, right? I'll change my computer to a whiteboard. I'll share my whiteboard with you now. Chapter 7, it's all about the rules of derivatives. But even before starting and talking about the rules, I will talk about two types of notation that we are using in derivatives to show the derivative of a function. For example, if you have a function f of x and you want to show the first, or you want to take the first derivative of this function, one of the notation that we show the derivative of a function, which is a new function, is the notation of f prime. When I'm writing f prime, it means the first derivative of this function f of x. If my function is g of x, if it's given as a g of x, then if I write g prime x, it means I'm taking the first derivative of function g. Same way, there is another notation of the derivatives, which we use d over dx. d over dx of f of x. It means we want to take the first derivative of f of x. The first derivative of f of x. But remember, d over dx is not a ratio. Some students, they are thinking that it's a ratio. No, it's just a notation. It's a operational notation for derivatives. Soon after practicing few problems, you will get familiar with these notations and you can use it very well. Now, the important part for us is to learn the rules of derivatives, and right now, if you learn these rules one by one, it's easy to handle derivatives. But if you forget about the rules, then you may do a lot of mistakes. I'll start with rule number 1. Rule number 1 is if you have a constant number, or if you have a function which is constant. If I write in notation in general form, if you have f of x equals c. C usually for us represents a constant, a number. For example, f of x equals 5. This function is a constant, and if you see the graph, all of us, we know what is f of x equal 5. Which kind of line is this? Y equal 5. It means 1, 2, 3, 4, 5, and you have a line, a horizontal line, correct? This is the graph of this function, which is a constant function. When you take the derivative of a constant function, the derivative of constant function is always 0. Or in other language, the derivative of a number is always 0. Then I can write f prime x is equal 0, always. Or if you want to write another notation, d over dx of a constant always gives you what? 0. For example, in this example, which is f of x equals 5, the derivative of this function, if someone asks me, what is the derivative of f of x equal 5? Then f prime x is immediately equal what? 0. This is the first rule about a constant or a number. The derivative of a constant or a number is always 0. Correct? Now, rule number 2. We call it power function or the rule of exponent. For example, if you have f of x equals x to the power of n. your variable to any power. For example, numeric example, f of x equals x to the power of 3. Your n is here 3, right? How to find the derivative of x to the power of n? The first derivative of x to the power of n, ddx of x to the power of n, what is the rule? Always, whatever the exponent is, bring it as a coefficient. Then your variable, and subtract always 1 from the exponent. That's the rule. N times x to the power of n minus 1. It gives you the first derivative of x to the n. For example, in this numeric example, d over dx of x to the power of 3 equals, I'll bring 3 as a coefficient, then x, and I'll subtract 1 from the exponent, which gives me 3x to the power of what? 2. We apply this rule in every single term of a big function. When they gives us, for example, a polynomial function, which is the addition or subtraction between few terms, we apply the derivative rule, the power rule on each term. And it's really easy to find the first derivative of a function, because if you go to use the formula that it was our previous lecture, it's much long and it's much difficult to find the first derivative of a function. But using the laws, it gets really easy. I'll do one more example on this. For example, f of x equals x to the power of, let's say, 10. Then d dx of x to the power of 10 equals 10 x to the power of 10 minus 1. There is no need that every time you write this, because you can calculate this by yourself and you just write the answer. But for time being, to show it for you how you find the derivatives, I'm writing every single step. Then this one will be 10x to the power of 10 minus 1 gives you 9. That's the first derivative, or you can name it f prime of x. If f of x is 10 to the x to the power of 10, then your f prime x is 10x to the power of 9. Question? Question on rule number 1 and number 2?
Is there any way you can go over that again? The link for the meeting was broken, so we couldn't get in.
Oh, really? I'm sorry. Which, only this example or all the lecture?
If you don't mind the whole, well, I'll just watch it later. You can continue.
Okay. Quickly, rule number 1, number 2, I'll go over. Actually, I'm recording right now this lecture and I'll post it later for you. If you missed the first part, you can watch it again, but I'll go over anyway. Look, rule number 1 is about a constant. If you have a constant function, for example, f of x equals c. C is a constant. Numeric example, f of x equal 2. The derivative of a constant is always 0. You can say d over dx, which is the symbol of derivative of c, always gives you what? 0. If someone asks you here, what is the derivative of f of x equal to? You can say f prime x is equal what? 0. The second rule that right now I explained was the power function. If you have f of x equals x to the power of n, how to find the d dx, or the first derivative of this function? D over dx of x to the power of n is, always bring your exponent as a coefficient. Write your x or any variable that you have, x, y, z, whatever the variable is in the function, and subtract 1 from the exponent. That's the first derivative of f of x equals x to the power of n. For example, if you have f of x equals x to the power of 7, then d over dx of f of x equals d over dx of x to the 7, which is equal, bring the 7 as a coefficient. Your variable is x, correct? And 7 minus 1, which gives you 7x to the power of 6. Clear now?
Yes, thank you.
Any other question on rule number 1 and number 2? Okay. Rule number 3, if you have a constant times a function, if you have c f of x, a constant times a function, how to find the first derivative of a constant times a function? For example, if you have 2x squared, you see your 2 is c, and x squared is actually f of x. How to find the derivative of the constant times a function? In general, d over dx of c f of x equals, it's like limits. Remember when we had like the limit of 2x as x approaching, for example, to 1, I told you you can bring this number to the front of the limit. You can write 2 limit of x as x approaching to 1, right? It's the same thing also with derivatives. If I have d over dx of c f of x, I can write as a c, then d dx of f of x. That is the rule of the constant times a function. Now, a numeric example. For example, this one, 2x squared. D over dx of 2x squared equals 2 d over dx of x squared. And now, I already explained to you the power rule. Then 2 times. What is the derivative of x squared? Bring the 2 to the front and subtract 1 from exponent, x to the power of 1 or 2x, which gives you 4x. Correct? I'll do one more example. For example, if you have f of x equals 5x to the power of 4, they're asking you to find f prime x. F prime x equals d over dx. It means the derivative of 5x to the power of 4. Now, I have a constant. I'll bring it to the front. Then this one equals 5 d over dx of x to the power of 4, which is equal 5 times. Bring the exponent as a coefficient. Your variable x, subtract 1 from the exponent, 3. Now multiply 5 times 4, 20x cubed. Question on rule number 3. Any question on rule 3?
No, just trying to write it down.
Okay, I'll wait for a few minutes. Did you guys receive the recording from our first Zoom meeting? I sent it last night.
Yes.
It takes time because I think the Zoom company is really, really busy nowadays. It takes them like a day to convert my videos and send it back to me. I just received it last night and I posted for you also. Now everyone, every single school is using Zoom. Every single office, they are using Zoom. Not only education, like other businesses too. Can I clear the board?
Yep.
Rule number 4, addition. If you have two functions, for example, f of x plus g of x, not only two, 5 of them, 10 of them, but in the rule we will explain 2 of them, right? The derivative of f of x plus g of x, it's similar what we did with the limit. For example, if you had the limit of f of x plus g of x, right? I explained to you that you can write as a limit of f of x as x approaching to a plus limit of g of x as x approaching to a, right? Same thing applies for the derivatives. Then d over dx of f of x plus g of x equals d over dx of f of x plus d over dx of g of x. This is what we call the addition rule. Same way, we have the same formula for subtraction. D over dx of f of x minus g of x is equal d over dx of f of x minus d over dx of g of x. We call these one the subtraction and addition rule of the derivatives. I will give you one more rule, then I'll start to do a lot of examples, and also I have your book here in front of me. I'll do some examples from homework. Then I'll assign today also a homework for 2.8, like only few problems, not more than 5 or 6, to just give you some practice. But before that, I'll explain one more rule also for you. Then I'll jump to examples. We remember f of x equals e to the power of x as a power function, right? We know number e and we know the graph of e to the x is something like this, correct? This is the graph of e to the x. Now, what is the first derivative of the e to the power of x? D over dx of e to the power of x is always e to the power of x. Remember, it comes in calculus 1 in different parts. In calculus 2, you will deal a lot with this. Just remember, the derivative of e to the x is always e to the x. It's not changing, correct? For example, if they ask you, find the derivative of d over dx of e to the power of 5, or let me go different way. Let's wait for time being. Any question on this first? Then I'll show it in another example to you. In 3.1, I gave you 5 rules. The first one was constant. Second, power. Third and fourth, addition and subtraction. And the fifth one, the dx of e to the x, which gives you always what? E to the x. Any question on these 5? Okay, now let's do some examples. Example number 1. F of x equals e to the power of x minus x squared. They are asking you to find the first derivative of this function. It means find f prime x. Then in part A and part B, they are asking you to find f double prime of x, the second derivative of this function. Remember, you can take the first derivative, second derivative, third derivative, fourth derivative, as much as they are asking. Because soon when we start graphing, we will use the first derivative and second derivative of a function that can graph the function, correct? Or the curve. Let's start with A. F prime of x equals that. This way of writing should be always your notation. When you are looking for the f prime, then f prime x equals d over dx. Use your operational notation, parentheses, e to the x minus x squared. Now, based on the subtraction rule, I can write d over dx of e to the x minus d over dx of x squared. We just explained as a formula, d over dx of e to the x is e to the x. Minus, here apply the power rule. Bring the exponent as a coefficient, then your variable, which is x, and 2 minus 1, which gives you what? 1. It means your answer is e to the x minus 2x. This is your first derivative, f prime x. Question on finding the first derivative? Yes, no?
No.
Okay. I'll erase the top part only, and I'll find now the second derivative of this function for you, part B. Now, to find the second derivative of this function, copy the first derivative in the top, f prime x equals e to the x minus 2x. Now, take again the derivative of this function. And if you do that, it means you're looking for the second derivative of the function. Now, f double prime x equals d over dx of e to the x. I'm sorry, e to the x, not ex. E to the x minus 2x. Again, the subtraction rule, f double prime x equals d over dx of e to the x minus d dx of 2x. d dx of e to the x again gives you e to the x minus d dx of 2x. You can write this one. You see, you can apply the constant rule here. You can write 2 outside, then d dx of x. And e to the x minus 2 times. What do you think? What will be the d dx of x?
Would it be x?
Let's see. It's interesting. I explained a little bit in your video when I did the video for you. Actually, I should give this one as a rule for you. D over dx of x is always 1. But let's see why it's 1, right? Look, d dx of x to the power of, actually, when you write x, it's x to the power of 1, right? Any number who doesn't have an exponent, it means the exponent is 1. Based on the power rule, you bring the 1 here and you subtract 1 from the exponent. It means 1 times x to the power of 1 minus 1. Agree?
Yeah.
Now, it will be 1 times x to the power of, what is 1 minus 1?
2.
0. Which gives you 1 times any number to power of 0 gives you what? 1, which gives you 1. That's why here, when you take the derivative of d dx of x, immediately you write 1. Then your answer will be e to the x minus what? 2. This is the second derivative of this given function f of x. Even right now, you can find the third derivative of this function if they ask you. Correct? After like practicing few problems, even you don't need a pen. What is the third derivative of this function? Immediately you will say, oh, e to the x. Because 2 is a constant, it becomes a 0, right? Any question on this example? Yes, no?
No.
Can I erase the board?
Yeah.
Okay. Now let's do some examples from your book. For example, problem number 6, 3.1. 3.1, problem number 6. G of x equals 7 over 4 x squared minus 3x plus 12. They are asking you in this problem to find g prime x, the first derivative of this function. Now, g prime x equals d dx of 7 over 4 x squared minus 3x plus 12. Again, you see addition and subtraction is together here. G prime x equals d dx of 7 over 4 x squared minus d dx of 3x plus d dx of 12. I am solving this problem in a long way to show all the rules for you, but later you don't need to do this, right? Immediately take the derivative if you can see it. Then g prime x equals, you see a constant times a function, then 7 over 4 d dx of x squared minus, again, constant times a function, 3 d dx of x plus, what is the derivative of a constant? 0. If you want to take the note, quickly write this. I will erase the top portion. Okay, actually I can erase the problem at least. Now, from here on, g prime x equals, keep 7 over 4, which is your constant, and take the derivative of this part. What is the derivative of the dx of x squared? It gives you 2x, right? Agree?
Yeah.
Minus, keep 3. What is the dx of x? We just calculate dx of x is always 1. Now, let's simplify a little bit. Which is equal, can I cancel this 2 with 4? 1 time, 2 times? Then my answer will be 7 over 2x minus 3 times 1, 3. This is your g prime of x, your final answer. Question on this example? Yes, no?
I'm still writing.
Yes. Can I put another example for you?
Yes.
Okay.
Yep.
Let's deal with the exponents, which they are in fraction form. I know everyone hates fraction, right? Let's practice, because you will deal in calculus with a lot of exponents that they are fraction. Problem number 11 3.1. I'll do one of your homeworks for you. GT equals 2t to the power of negative 3/4. Just apply the rule. It looks like fraction. It looks like a negative exponent. Please, at this time, do not change it to positive exponent. Do not send it to denominator because I didn't explain the quotient rule yet for you. Just what we know right now is the power rule and the constant rule. I have a constant times a function. Then I apply the power and constant rule here. Then I can say G prime T equals D over, should I write D over dx or should I write D over dt? It's important, whatever your variable is, you take the derivative of the function in respect to your variable. My variable is t, then I will write D over dt, not always D over dx, right? Whatever the variable is. D over dt of 2t to the power of negative 3/4. Now bring the constant to the front. G prime t equals 2 d over dt of t to the power of negative 3/4, which is equal to times. Bring the exponent as a coefficient, negative 3/4. Then t and subtract 1. Look, negative 3/4 minus 1. Go to the corner of your notebook and simplify this. Negative 3/4 minus 1. We need a common denominator, then here times 4 times 4, which gives me negative 3 minus 1 times 4 is 4/4. What is negative 3, negative 4? Negative 7 over what? Over 4. Then here 2 times negative 3/4 t to the power of negative 7 over what? 4. Last step, multiply. Can I cancel 2 with 4? Yes. 1 time, 2 times. Then my answer is negative 3/2 t to the power of negative 7 over 4. Easy, difficult?
Easy.
Easy, but because it's a fraction in the exponent, it makes you kind of, okay, what is this now? How to deal? I just did this example to show it for you that it's actually how to deal with the fraction. It's based on the algebra, right? The rule is -1. The rule is -1, exponent -1. And I did that and I simplified here for you. Correct? I will do one more. Can I clear the board?
Yep.
Look, an easy one, but you have to be always careful. For example, f of x equals negative x. They are asking you to find f prime x. Be careful. This one, when you write f of x equals negative x, actually, you can rewrite this one as a negative 1 times x, right? Now you have a constant times a function. Then d over dx of negative x equals negative 1 d dx of x, which gives you negative 1 times d dx of x is always what? 1. Then your answer is what? Negative 1. Easy, difficult?
Easy.
Easy. For time being, everything is easy. If you know the addition rule, if you know the subtraction rule, and the main one, which was the exponent rule, which you are using it every single minute, Then quotient and product is not difficult. Quotient is a kind of tricky. I will focus too much on that one to explain to you. And maybe you already heard from your classmates, from other students, oh, we are studying chain rule. Chain rule is really difficult. No, chain rule is really easy. I'll explain it in an easy way for you. If you know all these 8 rules, you are okay with the derivative. You can deal with any derivative problem, correct? Let me put one for you. If you have time, solve this one for me. For example, f of x equals a square root of x. Just tell me, who wants to tell me how to start with this problem?
Change the radical to an exponent.
Hmm?
Change the radical to an exponent.
Very good. Very good. That's the starting. Rewrite f of x equals x to the power of what? 1/2. Now go ahead, try to find the derivative for me, then I'll solve it here. Take like a minute. Think you are in a class. Any idea f prime? (1/2 x to the power of what?
-1/2.
Excellent. Let's see if this is the answer, right? Okay, f prime x equals d dx of x to the power of 1/2. Then f prime x equals 1/2. Keep your x. At the top, you will have 1/2 minus 1. In an easy way, if you think you have $1 and you take one half of it away, you mean here you will end up with -1/2, right? Or simplify 1/2 minus 1. You need common denominator times 2 times 2. Then f prime x equals 1/2 x to the power of -1/2. Final answer. Correct? One more fraction, I'll do fraction because there are a lot of fractions in your homework and you don't know the quotient rule yet. Let me show you that how to first change it to addition and subtraction because you don't know the quotient rule yet. Then use the 5 rules that you learned today. Everyone has time to stay with me like for a few more minutes?
Yeah.
Yeah.
Okay. Look, for example, I'll copy one from your book. Problem number 22, 3.1. Y equals square root of x plus x over x squared. I don't know the quotient rule yet. If I know the quotient rule, it's really easy. And also, if I go that way, I need also the chain rule, which I don't know it yet. Then how to kind of simplify this problem just to addition and subtraction. From algebra, you remember that you can move an exponent from denominator to numerator, but what we do, we change the sign of the exponent. Remember, if you have x to the power of n, it's equal 1 over x to the power of negative n, or opposite way, right? I will use this technique now. Then y equals, I'll keep the numerator, radical x plus x times, I'll move this x to the power of 2 to the top, which becomes x to the power of what? Negative 2. Now, again, I don't know the product rule. That's why I want to distribute. But as soon as I teach you the product rule, you don't need to do this anymore, correct? Then y equals, here, instead of a square root of x, I can write x to the power of 1/2 plus x times x to the power of negative 2. Now, using this formula, a to the power of m times a to the power of n equals a to the power of m plus n always, right? I will distribute and simplify it this way. Then y equals, I have x here, I have x here, x. 1/2 plus minus 2, it means 1/2 minus 2. What is 1/2 minus 2? I need a common denominator times 2 times 2. 1 minus 4 gives me negative 3 over 2. Then x to the power of negative 3 over 2. When you distribute this to this, your answer is x to the power of negative 3/2. Plus one of the x's between these two, when you distribute x to the power of 1 times x to the power of negative 2 gives you x to the power of negative 1. Now you see, I changed that problem to addition rule. Now easily I can use the addition rule of derivatives and I can find the first derivative of this function, which I will do it on the right side. Any question up to here? What I did was all algebra, right? Not calculus. Now, y prime equals d over dx of x to the power of negative 3/2 plus x to the power of negative 1. Then y prime equals d over dx of x to the power of negative 3/2 plus d over dx of x to the power of negative 1. Y prime equals negative 3/2 x to the power of, what is negative 3/2 minus 1? Let's calculate. Negative 3/2 minus 1. It means times 2 times 2. Negative 3 minus 2 gives you negative 5 over 2, right? Plus negative 1 times x to the power of, subtract 1 from the exponent. Negative 1 gives you negative what? 2. Then y prime equals negative 3/2 x to the power of negative 5/2. Positive times negative gives you negative x to the power of negative 2. Correct? That was a longer problem, a lot of algebra in it, right? Any question? Yes, no.
No.
This was all about 3.1. Soon I will send you 3.2. Today I will send you like 5 to 6 problems of 3.1, like for practice as a homework. And also Friday, hopefully, we will go over section 3.2. On Monday, I'll be online for you for the study guide. I will not do a lecture on Monday. I will go over a study guide, but before that, you will receive the video of the study guide also. On Wednesday, you will see your test will be ready on Canvas to do your first test.
So there's not going to be any lecture next Wednesday?
Next Wednesday, I'll give you kind of time to do your test. No, don't focus on lecture on Wednesday. Just do your test. Anytime I'll try to put a good window for you, like 12 or 15 hours, anytime during the day, but the time for the test will be limited. You can take any time of the day, but when you start with the test, I'll give you like, what do you think? Like 2 hours is enough for you?
Yeah.
Yeah.
I'll give you 2 hours to finish your test. You see, I'm on your side. I'll give you a lot of time, 2 hours. Say thank you.
Thank you.
Thank you.
Yeah.
Thank you.
Thank you, guys. Thank you. I know it's really difficult for you. Believe me, I am worried about you. I am worried about you, and I want to try my best because next semester, no one will teach you this book again, right? You will go to the next part of it, or some of you are done with your calculus. You have to learn something, and you have to pass this class with a good grade, not just C. That's why I'm trying like all the time to see what I can do for you. Don't keep the questions with you. Ask me questions when I'm online. Use my videos. I know they are not good, but still it's something. Ask me a lot of questions, okay?
Thank you.
Thank you.
Welcome. Any other question?
So Fridays we would normally have like a lab portion. Would that be still be possible, or how are we gonna do that?
It is possible for me. Yeah, I'll be at 8 o'clock online. This is my responsibility. Those of you that you have time, come online. I'll solve the study guide problems on that time. I will solve all of them, but I'll send you also a video of that. Today, I will solve all the problems on the whiteboard and I'll make a video of that.
Okay.
Yeah, but I will be online from 8 to 10:30 that day again.
Okay.
Any other question?
Yeah, the test, is it gonna be on like all of chapter 2?
No, the ones that you have in your study guide. Fully follow your study guide, not
Okay.
all,
Okay.
right?
Yeah. Thank you.
Good. Okay, if you don't have any other question for me, be safe, have a great day, and see you Friday. I'll be online at 8.
All right. Thank you.
Have a good rest of your day, guys.
Thank you.
You're welcome.
Great lecture. Thank you.